Hello, everyone. Good morning, good afternoon. I am going to launch a little poll here for you. If you don't mind helping us out, whether you're in the New York area or not, we would love to know your current feelings about on-site meetings, on-site technical training, things like that. So if you don't mind helping us out and going through these 6 quick questions, we would very much appreciate that. And I will give everyone a minute here to continue logging in, and we should be good. Do you guys see my poll?
Yes. Yeah, I
Yes.
do.
Yeah.
Perfect.
I recognize some of the names too. People in. I love
Wonderful.
that. Mr. Dangler, it's been forever. Long time.
All right. So while you guys fill out this form for us, I'm just going to do a little introduction here for Viscosity and the New York Oracle user group. So, good morning, good afternoon, wherever you're joining us from today. Welcome to today's webinar, co-hosted by the New York Oracle User Group and Oracle partner Viscosity. We've got a great presenter for you today, Craig Shallahamer from Viscosity. He's also an Oracle ACE director, is presenting for us today. Super excited to have him. This is a live webinar, so feel free to submit any questions you may have. Take advantage of the hour with Craig. I know he's a very dynamic speaker, so just put in your questions as he goes. He'll answer them as he can or following, however the flow fits. If you have any questions beyond that, you can respond back to myself or one of my colleagues who will follow up, and we can always forward those questions to Craig, either introduce you or get you answers to your question. All right, so real quick, I'm going to let Coleman introduce the New York Oracle user group for us. Coleman is one of the board members and the vice president of the New York Oracle user group.
Thank you, Monica, for the kind introduction. Uh, New York Oracle Users Group has been formed or was formed in 1984 for the exchange of ideas, assistance, and support among users of Oracle software products. You can reach out to us at LinkedIn, on what used to be Twitter is now X, and all the other places of social media that you can find us. We've been doing these webinars for the past 6 years with Viscosity, and we hope to continue and do more of the same with them. And I want to thank you all for attending this webinar today. Thank you, Monica.
Awesome. Thank you, Coleman. And if you're just joining us today, we just launched a little survey for the NYOUG on-site meetings, but please feel free to help us out, even if you're not in the New York area, because Viscosity also travels around and does a lot of on-sites too. So we would love to know, for our own purposes, as well as New York Oracle user group meetings, what speaks to folks these days about on-sites. And we're talking about days of the week, topics, how long of a meeting it may be, even what major cities you're willing to go to around you, would really help us. We would love to continue trying to get people engaging in person and meeting people in person again. Also, I think you just learn differently in person. So I know Craig would totally rather present this to you guys in person than online. And I think that's a lot of speakers as well. So it would really help us out if you fill out this survey for us. All right. So super quick about Viscosity. My name is Monica Lee. I am the Marketing and Operations Director here at Viscosity, where our mission is to enable business transformation at a time when companies must change to survive. And we are feeling that more than ever right now. These 3 pillars here are what Viscosity is built upon: data, apps, and cloud or infrastructure. And if anything you see across here speaks to any pain points that your team may be feeling, or a topic that is something you guys need to grow upon or have consulting and assistance on, if you need a solutions architect or expert to come in and help you guys just roadmap things, that's kind of what our team does. Across the bottom, you'll see that we also offer workshops, assessments, training, managed services across all these things. So let me know if anything here is speaking to you that you need help on, and I'd be very happy to chat with you. All right, on this page is just some of our leaders that are also in the Oracle ACE program. So hopefully you have seen some of these folks like Craig at a conference near you or at a webinar that you've attended. These folks are active in writing, in presenting, and hopefully you are familiar with them. And yeah, you can always reach out to them as well for any questions you might have. This page right here just showcases some of the things that we do that are most popular with our clients. I always like to point out Oracle License Management and near zero downtime migrations, I should say. But Oracle License Management, always great to have a partner like Viscosity, whoever your trusted partner is. Those folks can get you normally the best deals from any Oracle licensing. It's also just nice to have someone help with that relationship. They can bargain a little better with your Oracle sales reps. They can help you get and discover different discounts, or at the least, they can at least make sure you're only paying for what you need, and they'll follow up with you to make sure you are getting the best out of your investment. So I always like to recommend people to go through a partner for license management just because we have to do it more often than you do. So it's a little easier. And finally, Orapub is where Viscosity houses all of our webinar recordings and slide decks, and not just slide decks from those webinars, but also when we present at conferences around the globe, we have our team upload them here. So you can watch a whole bunch of stuff on Orapub, even as a free member. So if you're not a member there right now, I recommend going to this page right here, clicking on free membership, signing up, and poking around at all the different things. It's tons of free content there. Anything we do with NYOUG is also posted at nyoug.org. So you have those two platforms to go check things out. And with that, make sure that you are registered for all of our upcoming events and webinars at events.viscosityna.com. And I think with that, I will turn it back over to Coleman and we'll get started.
Thank you, Monica. So I just want to say a few words about Craig. Craig is a co-founder of Orapub and Viscosity's applied AI scientist. Having worked with Oracle technology since 1989, Craig Shallahamer is a leader in the fields of machine learning, artificial intelligence, and Oracle database performance tuning. He has received recognition as an Oracle ACE Director for his valuable contributions to the Oracle community through his technical expertise and leadership. Craig is an active participant in Oracle user groups, frequently presenting at conferences and serving as a board member and volunteer. I want to thank again Monica and Viscosity for co-hosting these series of webinars for past 6 years, and we'll continue to do them in the future. And thank you, Craig, for presenting today.
You're welcome. I was muted. Sorry about that. All right. I'm on.
You're on.
Coleman. Okay. Just want to make sure before I start, yakking and stuff. Yeah. Hey, thank you all for being here. And thank you, Coleman and the whole New York Oracle user group for having me. It's been over a year. I think January, I talked about AI coding. I think I did a little app or something crazy like that. But yeah, it's really an honor to be here. So today I'm going to kind of take you on a journey. It was like a personal journey, and it's about gift card fraud. And I learned a little bit about it, and I decided to kind of learn more about it. And I got really curious, and so I started going down this rabbit hole. And I was like, man, this is exciting. I'm going to figure this thing out. Well, it was super difficult before I was able to like crack the nut. I gave up multiple times. I thought I couldn't do it. I was committed to teach us to present this the first time at the Utah Oracle user group. And I was like, oh, I'm going to have to cancel. But eventually I figured it out. And so how I did that, that's what this whole presentation is about. So I had to make up a name for the bad guy, and so that's Slick Eddie. And we're going to catch Slick Eddie. He's the gift card fraudster. And what's kind of unique about this presentation, at least for me, it's all Oracle AI tech. There's no Python, there's nothing like that at all. It's actually just Oracle. And so that's actually pretty cool. I'm stoked about that. So actually there is Python, but I didn't actually code it, but most of it is actually SQL and PLC. In fact, I don't think there is any Python. I haven't looked at the code in a while. All right, so here we go. So imagine you are the like some vice president of operations, something like that, and you get an email like this, right? You look on your phone like, gift card fraud incident. You're like, this sucks, you know. So a couple things. One, how did this email like get generated? Like what led that to happen? And like how did the systems figure out there was fraud? It's one thing. The other is, well, if there is fraud, like what in the system allowed the fraud to take place? Right? Some fraudsters got in. Well, how did they get in? Like, where was the gap? How did they actually do this? So there's two things right there, and I'm going to talk about both of those. And then we have this fraudster, right? You got this Weasley looking guy in the green there. I love that picture. I found that. And so he's, Slick Eddie, and he's the leader of this organized like fraud scheme, gang. And there's four other guys that actually work with Eddie. Now most people think, well, that's Slick Eddie, right? Well, no, there's always somebody else behind it, right? And so the real Slick Eddie is this gal who no doubt lives in St. Pete in Florida, and she's fanning herself with all the money right there. But I'm so used to saying he and him for Slick Eddie, just whatever. But the real Slick Eddie is behind the Weasley looking guy. Okay. So how are these situations possible? Like, how did Slick Eddie actually like break the system and was able to commit fraud? All right. And then how did the IT gang or the fraudulent the fraud they're supposed to the fraudulent detector guys, God, what's the name of those guys? Anyways, the people detecting the fraud, how did they find out about the fraud? So it's both of these things are really the focus of this whole presentation. So yeah, Coleman, thanks for the intro. I really appreciate it. Yeah, my name's Craig, Oracle ACE Director. I'm a Viscosi's Applied AI scientist, and I'm a co-founder of OraPub. My wife, Katrina, who some of you probably get emails from. She's like a co-founder with me. So I started Oracle Tech in '89 as like a forms developer way back, and then I moved into performance tuning. Then that led me into capacity planning and predictive type work. And then thankfully, machine learning kind of started to rise again. And then the AI stuff just took off. And I just love that kind of thing. I love building things like software, not like physical things, and watch them work and improve. I've always have since it was like a kid. So this is why I just love all this, the machine learning AI stuff. What is super cool about this presentation is it actually contains like classic machine learning and like AI tech, and then Oracle. So it's like classic machine learning you're going to see. So I wanted to share with you this. Some of you heard me talk about Shane AI. In fact, one of you on the call here has actually used like the newest Shane, and that QR code will bring you right to Shane, so you can sign up. To use Shane now, you need to be at least a free OraPub member. I had to do that because it's so powerful right now that I'm afraid people are going to start abusing Shane, and it's going to cost a bunch of money and slow things down for everybody else. But what's unique about Shane, Shane is focused on Oracle performance tuning and internals in the tech, that kind of stuff. And Shane will actually lead you through the performance analysis. And he's shockingly, weirdly good. You can literally attach an AWR report and just say, Shane, what should I do? And you'll just go on a journey from there. You can go off different rabbit trails and all that. So click on the QR code, check it out. Let me know. I'm the one who does all the back end. I do everything with Shane. So you're talking to the right person when you talk to me. Monica talked about viscosity, great people. That's an old slide. Oh, I got my AI boot camp. I'm going to do it again. The first one was, I don't know, a few months ago. It's going to be September 22nd. Uh, that QR code will take you to the main landing page for that. So I taught this once for a customer, once for like public, and people they just loved it. Man, I had such good response to that, so I was real happy about that. And it's basically I get to teach with demos for a couple hours, and then we have like an hour lab where you guys do all the demos I did, and I'm like right there if you have questions. We have all sorts of really interesting conversations. Okay, so today. Here's the plan. What's Slick Eddie's scheme? I want you to understand that. Like, how can this thing even possibly work? You think with all the technology, you could prevent this from working. So it's really interesting how it can work and why. So we're going to have to understand how this gift card system works. You know, the gift cards, like when you go to, you go to a convenience store, it's just the gift cards, right? That kind of thing. So how does this fraud detection system work? What are the different pieces? What's the flow? How does this actually work? And then I'm going to, a key part of this is what I learned along the way. And man, it was super painful because I committed to do it and I just couldn't do it. And I was just like, oh man, I've already said this before, but man, it was so frustrating for me. Um, but anyways, eventually it worked. And I was just like, I was so stoked. So, and then you can download everything I'm going to talk about associated with this, all the PL SQL, all the code. There's a recorded demo. I'm not going to show you the recorded demo because I have screenshots and it's more useful in a presentation to just look at the screenshots. But the demo is on OraPubs. You can actually watch the whole thing if you want to. So that's what we're going to talk about. All right. So there's Slick Eddie. So here's how this scheme works. And I know somebody deep in the industry. This is how I learned about this. So if I say it's true, it's probably really true, unless I was misled by an industry insider. Okay. So here's how it works. Slick Eddie buys a $100 gift card and activates it. Okay. Then Slick Eddie creates 4 clones. Now remember, the cards have been activated. There's 4 clones, so there's 5 cards right now. Each card is actually a valid working card. All right, there's nothing. Well, it's weird, but they are like the same card. Okay, so there's 5 cards out here. Then the next morning, all 5 they go to the same city, but they each head to a different ATM. And this is one of those gift cards where you can extract cash from an ATM. That's how this fraud works. So it's about the same time. It's okay. It doesn't have to be like, this fraudsters probably should synchronize their watches, but if they're off a minute or something like that, it's not going to be a problem. So like at 9:47, all 5 of them will put they will try and withdraw $60 to $80. Nothing special, not too low, not too high, just a typical kind of transaction. It's that simple. That's how they actually do it. Okay. And if you think about it, if only 2 of them have a successful withdrawal, they've already made $20. So they can go, buy a 6-pack and then, consider themselves lucky they're not in a penitentiary yet. So supposedly this works. I'm told this actually happens. I would love to try it, but I don't think you can really test this stuff out, right? I don't know how to do that legally. All right, so how can this even happen? Well, it's the fundamental, like 1-2 word thing here is it's disconnected systems. See, in my life, in my background, it's been mostly Oracle. It's a relational database. We always have an application that's highly connected. We have primary keys. We have foreign keys. Excuse me. We have all that concurrency control. This is completely different. There are 3 systems that are used to use and activate, these gift cards. I was able to summarize and simplify those down into only 3 tables, 1 table for each system. Now, if you look at this, these are the 3 tables, these literally are the columns. I was able to simplify it this much. Now you might say, well, it's simple, Craig, because the tables are so small. No, that makes it more difficult because there's less information to crack the fraud, right? Fewer tables, fewer number of columns make it more difficult to actually crack the nut here. So the simplification was not to my advantage. Okay, just tell you that. So if you look at the tables here, there are no foreign keys. They're not explicit and they're not implicit. In other words, you can't derive them. And that is by design. So they're disconnected. Okay, so you might say, well, why would these systems be so disconnected? And let me back up. They are so disconnected. Each one of these is an independent system, can be a different vendor. There can be competing vendors that the gift card, whatever the main person is, they can actually switch to like another card activation system or another balance management system based on SLA, and problems and performance, all that kind of stuff. Each of these three systems can be owned, and usually are owned by different vendors, different data systems. They're not all Oracle. They could be who knows what. Okay, so they are very disconnected, which is just weird to me, that it's like this. And you say, well, okay, so why would they do that? Why would they do that? Well, it's to protect you and it's to protect me, and also for the vendor who could see everything, one vendor, so they're not going to rip us off. All right. So what this means is there's a ton of PCI type stuff, privacy laws, all of this is in there. And because we have all the privacy laws, all the PCI stuff, and the disconnected systems, which means there's latency when they communicate, that makes the fraud possible. And it also makes the fraud really difficult to detect because we got different systems with no foreign keys. Now I'm going to tell you more about the whole foreign key thing here coming up and the tables themselves. But there's three systems. The balance management system, what's the balance on the card? Do we have enough? The transaction system, anytime, first of all, you got to activate the card. That's the bottom right. Got to activate it. It's either on or off, activate or not. Balance, what's the balance? Do we have enough? That kind of thing. Every time there's an attempted change to the balance, that's recorded in the transaction management system or the TMS. Okay. And we'll talk a little bit more about those. So this is the standard gift card flow here. Remember, three core systems. You purchase the gift card for like $100 at a convenience store, that kind of thing. You activate it. That's that activation system. Okay. Then you can use it like some of them, depending upon the card and the agreement, you can use them like an ATM or like a debit card. And then when you actually try and use it, or you just say, hey, what's the balance? You're going to hit the balance activation system. And if the balance is attempted to be changed, you're going to have a transaction occur as well right there. So it's really elegant how these three simple systems work together without all the foreign keys. It's just crazy. So just a quick review how the scheme works. There's a extra step in here. And after the purchase, the second step, we have the activation. That's all normal. The third step right here, that's the clones, okay? That's the craziness right there. That's where Slick Eddie must have bought this little machine where you can clone these cards. So we now have 5 exact copies, and any one of those actually can work. All right. And so then everybody, the fraudsters go to the same city, different ATMs, and around the same time, they withdraw just like typical amounts. They don't want to show up as being anything strange. This whole flow, whether it's like legal or not, fraud or not, it's just three systems that are independently yet working together. So it's pretty amazing. So let's take a closer look at the data structures. I'm spending so much time on this because you need to understand, or it's important to appreciate how complicated it is to actually detect the fraud. And once you know that and you kind of understand this, then the process I go through to detect the fraud is actually, it's pretty, well, kind of straightforward. Okay. So Okay, let's look at the activation table here at the beginning right here. This is, I'm told that the rows are already inserted in this activation system whenever those cards are like put on the rack. They already have, whoops, they already have a row. Oh, I'm seeing this pop up on my screen here. There we go. The PAN, PAN, that's actually the card number. The card number is nowhere else on any of these three systems. That's the only place it's at, and that's highly protected. Okay. A vendor who actually is involved with the money here can't just say, hey, what's the card number for this person? No, 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 no. It's not like that. Okay. If they do get an answer, it's highly audited, and you don't mess around with that kind of stuff. So it's either activated, yes or no. Again, anytime there's a balance, money's put on, anytime there's an attempt to affect the balance, okay, the balance management system will be involved in this. And so you have this serial number. It says, well, that's the primary key. It is the primary key. And get this, it's derived or generated based upon, at least in part, on the card number. So this should be unique. Okay. And I don't say should. I mean, I believe it's the primary key. So it's got to be unique right here. Okay. What's really interesting about this, it's derived from the card number, but you can't go back the other way. So just because you know that this serial number is associated with one card, you don't know what card it is. Remember, these are disconnected and have all the privacy laws. So you just can't say, oh, I got the serial number. Who's the card holder? No, you can't do that. Okay. So then we have the current balance, the last time it was changed, and then when it was activated. Okay. All right. So that's the balance management system. That's gonna be touched a lot every time you use the card. And I just copied this up here at the balance management system, so you can see the relationship with the transactions. So this transaction system is truly a transaction log. This is used from a company so they can audit what's going on, and let's say like their checking account. This is the log that they can associate with the checking account, so they know if money is being put into the account or money is being taken out of the account. So this truly is like a transaction log. Okay. So it has a transaction ID. This is not a foreign key to the balances table. There is no key linking the balance system and the transaction system at all. Okay. Now you might say, well, wait, we got an activation time, or wait, we have the last change time, and we have the transaction timestamp. So that's just like where this time equals that time. No, that will not work, because these are disconnected systems, and there will be some kind of latency. We're talking speed of light network type stuff right here. Now they're close. At least you hope they are. Otherwise, we got big problems, right? And we can use this fuzziness to our advantage, but there is no relational database link going on right here. You can't create a view of all three of these. I tried, and my buddy said, Craig, you can't do that. That's illegal. Even if you could technically do it. Okay. All right. So we have the transaction ID. We have a token. The token is not a key. It's actually for security purposes, and they can actually be reused. Different transactions can have the same token. Okay. You have the type. There's two main types of transactions. It's called funds on, to put money, money was put into the system. Of funds off, the money's being withdrawn. Okay. Then you have the amount, the timestamp, and whether it was approved. So again, just because somebody tried to do a transaction, if it was declined, then that's actually recorded as well. Okay. So those are the three systems. So what we have right here. Oh, before I get to technologies, right? Yeah, demo. Okay. So let's talk about the technologies here. I was able to use Oracle for all of this, which is actually my goal. I'm used to using, Python and other stuff, but I really wanted to see if I could do this with all Oracle technology, and I really wanted to use Graph. I wanted to use Oracle's, PGL property graph and all that kind of stuff, and I just had a hunch that it could be done. So everything, you can do this in 26 AI. And I did all of this in a free tier on OCI, and it works. And it was free tier was beautiful. It was super simple. All the networking stuff was, which is usually a nightmare for me in OCI. It just worked right away. Okay, so in order to for all this detection to work, I wanted to use vectors. Okay, and Oracle and 26 AI, we have a vector column, and you can index those vectors, which is not trivial to index vectors because vectors are essentially an array of numbers. So, if you think about a tree, that's weird, right? It's not a trivial matter to index vectors. So I do want to say that a vector is just truly another type. Like an integer is a type, or a string is a type, or a blob is a type. Okay, it's a type. To say Oracle is a vector database, that's like you're shrinking the impact and power of Oracle when you say that. It's just a type. Okay, so in 26 they have probably 19 too as well, but we can do similarity searches. Like this vector is similar to this vector thematically. We're going to talk a lot more about that. Um, we can also embed, like in SQL, embedding is taking like a string of text, and what you get out of that is that a vector, an array of numbers. And because of it's a vector, you can use some distance functions to determine, well, how similar are these two vectors, which is another word of saying how similar are these words or this chapter in a book or this page or this picture, that kind of stuff. So it's actually in SQL, which is super cool because since it's in SQL, you can have all the where clause type stuff as well as the machine learning stuff. Um, Now, Graph, like I said, I really wanted to use Graph to do this. So this is the setup for the property graph, which we'll talk about, just a little bit more. So each transaction here, these are transaction IDs, 1014, 1015. So these are transaction IDs, and they're going to be in time order. I guess there could be a type, but it's pretty close. But I guess technically maybe it could. I don't know. So the relationship between these with these transactions is time. It's the time delta, and that's called the edge. And from a graph perspective, okay. So each transaction has properties. That's why it's called a property graph, right? But it's from a database background. Each one of these nodes is a row in a table or a view. Okay. And you think about it, well, of course, we have columns, the transaction ID, the type, the amount. Those are the properties of the node, of the row. So it makes so much sense, at least from a relational database perspective. It just kind of works. It's just another way of relating data in a graph form, but the data is the rows in the table. So when you create like a create property graph syntax, it's boom, it happens just like this. It's DDL. It's like creating a table. Except you already have the data with the property. Well, I'm assuming you have the data. No, you don't have to have the data, but you're going to have the underlying tables are going to need to exist. All right. Anyway, so once you've got this graph like created, the DDL, just like with the table, you're going to want to use it. There's, like inserts and, so you're going to want to use it. Well, in graph, you're going to want to traverse the graph, like go from this transaction to that transaction, or from 1014 to 1016. You can jump around, you can move around in the graph. You can do that with what's called PGL, that's property graph query language. And it's literally in SQL. If you ever seen the match syntax, it's a freaking nightmare. Thankfully, I have AI coding because I don't want to learn how to do all that matching stuff. But that's how you actually traverse the graph, and it's in SQL. Now, you might be thinking, okay, Craig, what's the big deal? The big deal, if it's in SQL, all the cool SQL stuff that we have because of SQL and Oracle, parallelization, all the relational like math, all the set theory, all that's inherent in all the operations of the traversing. So it's a super big deal. Okay. All right. In addition, I use an LLM because once I detected the fraud, there's a bunch of information about the fraud. And that's part of the prompt that is given to the LLM to create the email, like I showed you at the very beginning of the talk here, that the VP of Operations received. Okay, so there's a lot of Oracle technologies. There's AI stuff. There's machine learning stuff. It's super cool. Okay, so creating the demo data. This is actually important because I'm hoping you're in a couple of minutes you're gonna have like an aha moment. Oh my gosh, this is crazy difficult to do. Okay, so I tried to get an LLM to create the data. It failed every single time. I could not get the consistency, so I had to use AI coding to actually create a Python program to actually generate my demo data. So essentially, what I've done, all the demo data is there's the balance table. That's it. Really simple, right? Hardly anything there. But the main data is all the transactions. You got just a ton of transactions. And so essentially what I did is I just had to create a bunch of transactions, picture just a bunch of them that are just normal, transactions. And then I said, okay, this is the fraud that I want you to take the fraudulent transactions, including the funds on right here. I wanted to have that in there too, okay? Because I needed to know like that starting balance. So I wanted it in the data. But basically, it's got to take these fraudulent transactions and just kind of spread them out through all of the transactions. And these transactions are very specific in terms of the timing, the order. Notice the $60 and $80 right here. Some of them were approved. In fact, too many were actually approved. That's you can see the fraud take place. The system kind of caught up, and so then the final two were actually declined. Okay, so this is a very specific type of gift card fraud. I don't know if it has a name. Well, actually, it does have a name. Actually, I forget what it is, but it's one type of fraud. And when I learned that, hey, this is one type of fraud, I'm like, well, what do you mean? Well, it has certain characteristics. When I heard that, I'm saying, hey, that's like a thumbprint. This is a type of fraud. There's going to be all sorts of different all sorts of different, amounts and slight timing differences and all of that. But it's a very specific fraud that has certain characteristics, and I can represent that kind of like a fingerprint. And I'm going to use that coming up. Okay. So what we have here now is, if I go to the next slide here, is that's just that page is just so it's like a record, so some stuff, details. Okay, this is what I want to show you. We have all these transactions listed, and there's more of them. They go down below the slide here. Okay. We have all these transactions. Most of them are just perfectly normal transactions. You see the funds on and the funds off. You see the amounts, all sorts of amounts. Kind of spread throughout there is the 5 fraudulent transactions. Okay. And like the mission, right, that I chose to accept was to somehow, knowing this information, this balance record, since it's now negative, we have exceeded, we got fraud has been committed. Somehow, once I noticed that, now I have to go through these transactions and I need to somehow figure out which transactions, the path, this transaction, which transactions that are scattered throughout there were resulted in this one line right here. Here's the serial number, ending balance, when the card was activated, when was the last attempted change of the balance. That's the information I have. One line, all these transactions. Okay, Craig, I need to know the transactions involved in the fraud. Right. Okay. So that's the trick. How do you do that? With no foreign keys with this disconnected system. Okay. So I got like 20 minutes left here. So here's the solution. This is how I cracked it. My initial thumbprint, my initial thing all about the thumbprint was there's no way I'm going to get all those transactions in a graph, because while I only have I have just over 100 transactions. That's all I used. Okay. But in real life, I, I can't just scale that to infinite size and expect that to work on any property graph. It's just going to blow up memory. It's going to be a freaking nightmare. There are not just millions, we're talking trillions and whatever comes after that. All the connections. It's not going to work. Somehow I have to reduce this. And so it's the whole similarity search thing. Okay. So here's an example of this. So what I've done is I took basically, it's almost like a picture of this thumbprint. Identifies this type of fraud. And I vectorized it. I took characteristics about this type of fraud and I converted it into a vector. And I'm going to show you exactly how I did that. Okay. A vector is basically coordinates. Now, in this case, I can plot these in 2 dimensions. So there's 2 coordinates. There's an X and a Y. If I had 3 coordinates, if the vector had 3 dimensions, it would be like an X, Y, Z. If I have four dimensions, now remember, a dimension is like a column. It's a feature. It's an attribute of the fingerprint, of the row of data. Okay. So if I had 3 dimensions, I'd have an X, a Y, and a Z. That's what we would have. So I can plot these in 2 dimensions if I reduce the dimensionality of this. Okay. So I have a fingerprint. So what I'm going to do, I'm going to take groups of the transactions. I'm going to take like this group of transactions, that group, that group, that group. And I'm going to vectorize. I'm going to create a fingerprint on all the different clusters of transactions. And then I'm going to plot them. And I'm going to see which ones of these clusters is similar in terms of its attributes with the actual fraud fingerprint. And then I'm going to take, for example, I would say, okay, well, if I look at this, fingerprint 2 and fingerprint 3, they're contained within all those transactions. They are relatively similar to my fraudulent fingerprint. My hope is that those fraudulent transactions, there's 5 of them total, right? Because for all the 5 cards, remember the clones and the original. If they are similar characteristics of the fraud, then I might be able to then say, okay, the fraud is probably contained within either this vector 2 or this vector 3 or vector 2. And so what I've done, I've taken potentially hundreds and thousands of transactions. And I said, you know what? I'm going to focus on just these 2 clusters right here of transactions. And my hope is that the fraudulent transactions are just within these 2 instead of these like hundreds or thousands of fingerprints. That then allows me to create a property graph in memory, and I can actually traverse that property graph because this needs to be fast. Right? This is like money is just pouring out of the company when this fraud's happening. Okay, so that's a big part of this. So essentially what we're going to do, the strategy is like this funnel strategy. All the transactions have to go in there, as well as I know I have a negative balance. Okay. And so this is the heart, and I'm going to kind of walk you through some of this. But so I start with, I have 103 transactions instead of thousands. But if it works with 100, it's going to work with thousands because of this clustering. Okay. And I'm using free tier database to do this, right? Yeah. So I have 103 transactions and I created clusters, and I'll explain these clusters, but the clusters are just a bunch of transactions. So remember the transactions I had listed? So this is like the first cluster. It's 2 minutes worth of transactions. And then I'm going to move 30 seconds down. And this is the next cluster. Notice there's overlap because I want all of the fraudulent transactions to be in a single cluster. So it's really similar to the fraudulent cluster. All right. So that's the first cluster, the second cluster, third cluster, fourth cluster, fifth. That's it. So with 103 transactions with 2-minute windows, okay, it turns out there was like 15 clusters. All right. Which is so doable, right? And then I do a vector similarity search. I say, I'm just going to take the top 5. In terms of, this is my thumbprint. All the other thumbprints are all around it. I'm going to get the 5 closest. And then I'm going to have a bunch of transactions. I'm going to dedupe the transactions. So there's only 20. Okay. Now I can create a property graph with the 90 transactions. But get this, there's still like 3.7 million candidate paths because I need 5 transactions, all the different connections, and I got to count to 5 in each one of those. It comes out to like almost 4 million. That's why I needed to go through the similarity search at the beginning here. Okay. Then after I actually traversed the graph with some constraints, okay, based on what I know, that actually was able to get down and I was able to extract. This is a select statement, by the way. So the result of the select statement is like transaction 1014, transaction 1022, transaction 1104. That's the output of the select statement. It's the path of the transactions involved in the fraud. Well, it turns out at this point there was 132 valid, right? So far they're valid. Transaction paths, which is like amazing that I was able to get it down. I was just like, dude, this is so amazing. Okay. Then with the 132, I applied even some more specific, I'll say, constraints. Like, the money's got to match the ending balance, and you add up all the fraud and approved, declined, all that stuff. Also, remember we do know some timing information, but the timing, like the transaction log timing, and then the last attempted change that's recorded in the balance system, those are not going to be equal because these are disconnected systems, but the timing is going to be pretty close. So I did kind of like a fuzzy plus or minus search. And that's how I linked them together. Okay. Now, 2 seconds plus or minus for a financial system, man, that's like really generous. So, if I had too many fraudulent paths like come out of that, I would just start reducing that 2 seconds. I didn't need to do that. This is a demo, right? Once I did this final path check validation, only one fraud path came out. Turns out it was path 777. I don't know. What do you think about that? And that actually was the correct fraud path. So somehow going through all of this, right, applying it to this, I was able to successfully rip out of there the 5 fraudulent transactions. It's amazing how it worked. And so once I got that, now I have some information about the fraud. I can take that information, I can add it, I can augment a prompt, an LLM prompt, to create the 2 different emails that I actually want to send out. This whole thing takes just a couple minutes to do on a free tier. So let's talk about the vectorization part right here. So this initial fingerprint is basically a number of different characteristics about these transactions right here. Okay, so these are some of the some of the attributes, like how many transactions were approved. 3, 1, 2, 3. Okay, how many were declined? 2, 1, 2. I mean, it's data, right? They're attributes of the fraud, and these are column values. Okay, like the approved or not. So if you think about it, right, it's column data based on 5 rows. We call them rows and columns. In machine learning, they're called maybe attributes, but they're called features. These are features of the fingerprint, features of the fraud. So these are just a bunch of features or attributes of the fraud. And you put those together, it's like 5053. There you go. 5053. That is the vector. These are the coordinates where this fingerprint resides in like vector space. Now I showed you in 2 dimensions, so you would have to do some dimensionality reduction to go from however many there are here. I don't know. I think there's 13, something like that. I would have to reduce those to 2 so I could actually plot them. Okay. So that's how I get my initial fingerprint. Now, for each of those clusters, okay, these are remember those clusters I took right there? These are like, this is an example. These are the transactions in cluster ID 27, 28. These are its transactions. So there's going to be some overlap. You can see some overlap if you look at these, and it's supposed to be. Okay. So each of these transactions, I then vectorized them. They all have, different features, feature values. And so that's like, you can see all the different features right here. Each of these is a fingerprint. And my fraud fingerprint is like here. Each of these is another fingerprint floating around. Because this is the fraud fingerprint, I want to get the closest fingerprint to it. And my hope is the transactions contained within that cluster are those 5 transactions. Okay. So what I did a similarity search, that distance search, right? And so in this case, because it's the distance, the lower the number, the closer it is. It's the distance. If I'm looking for similarity, I want a high score. But I just used distance right here. So this cluster 41, was the closest. But I can tell just by looking at it, well, I have to have 5 transactions. There's only 3 here. So there's no way that this is, so I can automatically like throw that one out. That's like not thinking, but that's some constraints. Anyways, so I took the top 5 right here, and that's going to contain all of these transactions. I deduped those, and then those are the transactions we're going to start creating the property graph from. Okay, so this is a huge thing, and it turned out to help me out pretty good. Now I define the property graph. So with what I have, there's just over 4,000 edges. Those are the connections between all the different transactions. Okay, notice how long that actually took to create the property graph. Step 3, dropped and created. Oh no, there's the creation right there. It's basically 0. It's DDL. The point that I want to get here is that creating the graph, defining it, is like creating a table. Okay. However, when you start actually traversing the graph, you have a select statement where the output is the different possible fraudulent transactions. It took almost 2 minutes 2 minutes to actually go through the property graph with some constraints. These constraints are applied in the where clause and within the match statement of that PGQL. Now you might say, wow, 2 minutes sucks, Craig. Yeah, it actually does suck, okay? But think about it. This is running on a free tier autonomous database, which gives me what? A fraction of a virtual CPU, like nothing, okay? So basically, there's no parallelization. I just miss out on that. Okay. So the fact that it finished in 2 minutes is freaking amazing, man. I can't imagine. I mean, so in my mind, this would actually scale. So now, when I created this property graph, it turned out there was 132 valid paths, and these are the paths so far that have kind of made it through the funnel right here. 132. Turns out this one actually is the fraudulent path, this path 777. So it actually showed up. Oh, in fact, in the previous screen right here, the fraudulent path is in this 3rd ranked cluster. So it actually was there. Okay. Okay. Now, now that I have those paths, now I just apply some additional constraints, like that fuzzy time match. I make sure the balance matches, of our balance. If you add up all the fraud and what's the ending balance of their account, you just do stuff like that. And so there's a checking of the balance and a checking of the timing, that plus or minus right there. And both of those have to they pass before the fraud could potentially be valid. So right there's my 777 at the top. Now, you'll notice, though, that there are some other matches for both of these, but they only had 4 fraudulent transactions. And so the rule for mine was really I took the one at the top, but I was looking for 5. That was part of it. Now, what would happen if I had another path that had 5 fraudulent transactions that match both the balance and the timing, which is which is totally possible. Okay. What I would do, I'd start taking that fuzzy match and say, instead of plus or minus 2 seconds, I would start tightening it until one of those dropped off, and I'd probably go with the one, that kind of thing. So this is a demo. It's not optimized. It could go a lot faster. In fact, there's, as I went through this, I'm always thinking about ways that you could make this thing like legit. In fact, I didn't tell anybody I was doing this except for viscosity and my buddy. I was working on this. I didn't want to talk too much about it because I'm thinking, yeah, this is pretty cool. Could you actually use this? So once the fraud is detected, then I have basically all this information. I now know the serial number associated with the transactions, which is right. I had to figure that out. That's part of figuring this out. At this point, I could probably go to some activation system vendor and say, listen, I got a serial number that has serious suspected fraud. You might want to let the card holder know. So they could probably do that, highly documented, regulated, all that kind of stuff. Okay. All right. And then since I know this detail right here, I can give that to the LLM. I can have slightly different prompt. One prompt is going to create something for the VP of operations. The other prompt is now going to give more detail to somebody who has to investigate the fraud. Okay. The demo, that kind of was the demo. If you want to watch the actual video demo of it running, you can just go to the website for that. Okay. Okay. So this is kind of in summary here. This is good. Where I'm actually gonna like get it done. Hope you guys are still with me here. Can't
Still
see
with
your
you,
eyes.
Craig.
Hmm?
There's a couple of Q&A, Craig, you may want to address at the end.
Oh, okay. All right, good. All right. Then let me I didn't see those. Okay. Okay, I definitely will do that. Okay, where I got derailed. The first thing was I didn't know anything about this. And because of the disconnected three systems, using an Oracle database, it's my background. It took me like forever to understand how this actually worked and how it was actually possible. So my friend, his name's Troy, he spent so much time texting and talking to me just as I would just go around and around and around until I finally like got it. Okay. My initial hunch was the fingerprint. That's really what cracked the nut because if I didn't do that, the property graph was just like there's no way to do the appropriate traversing on that. And through the AI coding kind of got me off of that. And then I finally said, no way, it's got to be part of it. So I forced it back. And then we finally made some progress. What really made it really work, once I stuck with my hunch and I used the best coding model I could get, and I used Sonnet 4.6 was just released. Then the coding agent was able to code this stuff for me. Okay, you say, well, why is that a problem? I mean, why is it so difficult? It's because LLMs are trained on data, right? Actual like PL SQL code and understanding this whole how this fraud is possible and understanding gift card stuff. These LLMs don't have much knowledge about that, especially coding. When the LLM saw I'm working with Oracle, they're thinking relational database. Yeah, Craig said disconnected, but whatever. They absolutely must have foreign keys because why would you use Oracle with no foreign keys? That doesn't make any sense. And so it kept like forcing foreign keys. I was like fighting the AI coding agent. It's because it didn't have the training or the knowledge. Doesn't have it. Has more now because it saw all the data, training data and stuff I gave it. Anyways, so the LLM was relentless trying to create foreign keys. It was infatuated with tokens. Oh, that must be the foreign key. So much so, I actually had a couple sentences that whenever I started a new chat with the AI coding assistant, I would literally paste these in here. This is a disconnected system. There are no foreign keys. This is by design. It's not a mistake. And by the way, the tokens are not a foreign key. And that actually helped the LLM every time I would actually do that. Okay. All right. So that's the end of that. If you want to download everything and all that, take a screenshot of this. I'll answer your questions in just a moment. Okay, got that picture? If you want to check out Chain, there's the QR code for that. Boom, go there. And the boot camp, I got another QR code. If you're interested in that, you can go to orpub.com, but there's the QR code for that. Okay. Oh yeah. The bars don't slide very well. So I just boom, they're slick Eddie behind bars. Okay, let me look at the questions right here. Okay. Let's see. How do I see those? Um, I'm gonna need some help here.
Shall I
Uh,
read them to you, Craig?
yeah, oh, the Q&A, here we go. Oh, got it. Any reason why the table and column names are lowercase? No. Uh, don't know about that. That's a good. I didn't even thought about that. No, there's no particular reason. How could you have the fraud vector be the fraud vector? Oh, because before knowing the transaction. Okay, so I was trying to like crack the nut on a specific type of gift card fraud. And my friend said, because I've heard him talk about a very specific type of fraud that they have to deal with. There's many other ways to defraud the system, but this was one specific way that he was able to publicly talk about. And so I said, Troy, I said, tell me more about this particular type of gift card fraud. And so once I understood that, then I said, okay, these are the transactions that I want to use that for this fraud, this type of fraud. And he says, yes, that's correct, Craig. That's an example of this type of fraud. So I use that to create the fingerprints. So if you think about this, you could have a number of different fingerprints, different frauds types, or similar, just a little different. And you could have a number of fingerprints. So this thing could scale out to all sorts of different types of gift card fraud. I was just looking at one. Okay. So that's how I was able to actually do that. Craig, Mike, so good to see you there, man. Two questions. I use 60 and 80 amounts. But if I were a bad actor, I would go for small length. Okay, here's the thing. This is super good. I thought a lot about this. I talked to Troy about it. Nobody really goes for $10. I don't know if you can get $10 out of an ATM, right? It's usually, 20s, right? So the deal is that we didn't want the amount to fire any red flags. A bunch of small amounts, that's kind of, that'd be really unusual. And the anomaly detector would catch that. A really one big one transaction, boom, it would just decline that right away. Multiple typical transaction sizes, that's not going to be flagged. That's why I actually picked that. Okay. Let's see. Then why the duplicate cards? Oh, because you want these to happen at the same time. This is all about latency. There's no concurrency control right here. So if the balance system says, hey, there's money because it's waiting for something else to happen, it's going to say, yeah, sure, we got money, but really you don't, but because there's no concurrency control. It's the disconnected systems and the fraudsters get in the middle of that. And they don't know if it's going to work or not, but they know it can work. And so they get a bunch of them going at once. I just picked 5 transactions. Troy told me that you can have a gang spread out all over. And all they have to do is get a few of these people to be successful, and boom, they make some money. All right. All right. Great questions, you guys. I think that's it. All
One
right.
more, Craig.
There is? I don't see. Yeah, how do I get? Oh, there we go. There we go. On the legal side, isn't it completely absurd that a gift card number does not appear logged? Yeah, but that's called privacy laws. Privacy laws, PCI, all that kind of stuff. That's right. Because once somebody knows the gift card, once they know the number, then it makes it much easier to commit fraud, I'm told. Okay. And that's why they do. Yeah, it's crazy. I know. I know. I agree. But then I don't want people to make it easier for fraudsters to get my card number too. It's like I don't want them to get my social security number kind of thing. Yeah. It's a special number. Yeah. All right. Great questions, you guys. Thanks for listening and actually questions. I really appreciate that. All right, Coleman, I'm done.
Thank you, Craig. Monica, some final words.
Yes, thank you so much. So, quick reminders to everyone, today's webinar, the recording will be posted to nyoug.org as well as to orapub.com. gnarly.com.
Mhm.
We will send out an email once it is posted. Give us like a day or so. It normally takes our team a little bit of time to get that up there. Slides will
Mhm.
be there as well, and anything else Craig may want to share, we'll post
Mhm.
alongside. But otherwise, let us know if you have any other questions for Craig, or you can reach out to him. His email is right here on the screen, craig.shallahamer@viscosityna.com.
Mhm.
Anything else? Again, you should have a follow-up email from myself or my team, and you're welcome to just reply there. And anything else, NYOUG, are you guys going to do anything soon in person? I know you had a recent.
Yes, as a matter of fact, Monica, we're planning to have on site tentatively scheduled for the end of September, specifically on the 30th. And while we're talking about that, Monica, do we have the results of the survey?
Yes, we do, and I will forward them your way. Hopefully, it helps. Thank you to those of you who did participate in our survey. We'll probably try to do this at the next few webinars as well. So if you've already answered it, no worries about answering it again, but hopefully we can get a lot more information. I think I've got 15 responses, which is nice. Thank you
Fantastic.
guys.
Good
Yes, thank
response.
you guys so much. Craig, thank you so much for your time. Always so fun to watch and
Yeah,
hear
you're
you.
welcome.
So we're
Thank you,
looking
Craig.
forward
Yeah,
to
thank
what
you.
you have coming up.
All
All right.
right.
Oh, actually, Craig will be at
What?
Kscope as well. So if anyone
Oh
here is
yeah.
headed to ODTED Kscope, you can catch Craig there. He's
Mhm.
got a session, and I think we've also got Rich Nemec from our team who will be there as well, and one of
Yeah.
our Apex developers, Rodolfo Rodriguez. So if you're there, come find us. All
All
right.
right.
Thank you guys so much. I hope
Bye,
everyone has a
guys.
beautiful week. Take care.
Bye.